vast sky invites only the bravest conquerors. Boundless Earth is the stage for the most determined souls. As time passes, China's manufacturing industry advances with vigor and determination, stepping boldly onto the global stage and contributing to China's rise as a manufacturing powerhouse. Soaring through the skies, bridging vast divides, and conquering the impossible. One after another, groundbreaking, mega equipment, and projects are emerging, unleashing immense strength and energy to boost China's manufacturing might. Runway 4 cleared at Shanghai Pudong International Airport. The C919, tail number B001J, slowly taxis into position. At 6:52 a.m. the plane takes off. After a 3-hour and 2-minute flight, it successfully completes all scheduled tasks and lands smoothly. The first test flight of the first C919, soon to be delivered to its first customer, concludes successfully. The development and manufacturing of large passenger aircraft is a key indicator of a nation's aviation capabilities and overall strength. The C919, China's first mainline commercial aircraft designed to international airworthiness standards, has a capacity of 192 passengers and a range of 5,555 kilometers. Over its 7-year development, hundreds of thousands of industry professionals contributed to its success. Runway, a forging press operator, is about to work with this national treasure-level heavy equipment, showcasing the incredible strength of China's machinery. The world's largest 80,000-ton forging press, designed and built independently by China, stands at 42 meters tall, weighs 22,000 tons, and has hydraulic pipes stretching 10 kilometers. This massive press is crucial for producing forgings for aerospace, power, petrochemical, and other sectors. Only a handful of countries can develop large forging presses. Previously, the US, Russia, and France were the only nations with presses over 40,000 tons. The emergence of the 80,000-ton forging press now positions China as a leader in the highest level of forging equipment globally. With a single strike, the 80,000-ton forging press generates up to 100,000 tons of forging pressure, allowing seamless forging of metals at any tonnage, achieving precise integral shaping. Runway, calm and focused, gently moves the lever, slowly shaping several tons of metal. Since successfully forging the first landing gear, Runway's team at Zhong Heavy Equipment has produced 70% of the forgings for the C919 aircraft.
When working on these aerospace forgings, I often think that one day, the plane I board might be equipped with parts I personally forged. With our 80,000-ton press, we're constantly exploring and developing new products. We never stop pushing forward in our quest for excellence. In the future, we'll deliver even more high-quality aerospace forgings from this national treasure, our 80,000-ton press.
The 80,000-ton forging press, dubbed the king of heavy machinery, pushes the limits of human manufacturing. Today, with the rise of even greater manufacturing achievements, more Chinese equipment is stepping into the global spotlight. The Shanghai Tibet Plateau is known as the Earth's third pole. Over the past 15 years, 100,000 Chinese railway workers have overcome three major engineering challenges: permafrost, high altitude, and fragile geology. With wisdom and courage, they successfully laid the sky road on the roof of the world, shattering the old belief that trains could never cross the Kunlun Mountains. Today, as Fuxing high-speed trains race across the Shanghai Tibet Plateau, new miracles continue to unfold at an astonishing pace.
Fashian Pass.
The first major pass on the Sichuan-Tibet section of National Highway 318. The under-construction Sichuan-Tibet Railway is advancing into the Hengduan Mountains. Spanning 1,567 kilometers, it will be China's second railway into Tibet. Once completed, travel time from Chengdu, Sichuan to Lhasa, Tibet will be reduced from 36 hours to about 12 hours. However, this is considered the most challenging railway project in human history. The Sichuan-Tibet Railway will cross 7 major rivers and scale 8 snow-capped mountains over 4,000 meters high, with a total elevation gain of 14,000 meters. The Shirjala Mountain Tunnel, stretching 37.96 kilometers with a maximum depth of 1,406 meters, will be China's longest railway tunnel upon completion. However, built at an altitude of 4,700 meters, this mega-tunnel faces numerous world-class engineering challenges, including high-intensity earthquakes, high ground temperatures, and extremely hard rock formations. Inside a massive factory, the CREC 1098 hard rock tunnel boring machine takes shape. With an excavation diameter of 10.23 meters, it weighs 2,500 tons and boasts a power output of 7,600 kilowatts. This formidable tunneling titan, driven by electric motors and propelled by hydraulic systems, crushes rock with an efficiency 5 times that of traditional drill and blast method. On the assembly platform, a 155-ton steel structure stands solidly. It's the main beam of the CREC 1098. As the core load-bearing component, the main beam supports various system attachments, which can weigh from a few tons to over 100 tons. The right tools lead to success. The hard rock TBM, hailed as the king of engineering machinery, is a key indicator of a nation's manufacturing prowess. Lacking core technologies, China's TBMs were long reliant on imports and subject to external controls. Independent development of hard rock TBMs became China's only path forward. From imitation to innovation, Chinese manufacturers have, over more than a decade, gradually broken the Western monopoly in this critical field.
In fact, I believe this process is fundamentally about learning and improvement. When we first started making tunnel boring machines, we relied on foreign standards for domestic manufacturing. There were many aspects that didn't quite match, so it was a mutual learning experience, with us mostly learning from abroad. We then innovated in manufacturing processes and technologies to suit China's specific conditions. More importantly, we've developed our own comprehensive manufacturing system.
Final assembly is nearly 60% complete, and the intricate, detailed work has begun. Welding, grinding, connecting, fastening. These operations are second nature to the engineers, yet they cannot afford a single mistake. The oil pipelines are the veins of the hard rock TBM, delivering hydraulic oil to various parts. The quality of assembly directly affects the release and control of its 27,000 tons of thrust. The hard rock TBM comprises tens of thousands of parts. This is no easy task. Just 2 hours after completing the oil pipeline assembly, an even greater challenge emerges. The main drive unit, weighing 270 tons, is the heart of the hard rock TBM powering the cutter head. Now, engineers must use hoisting to seamlessly align the main drive unit with the main beam. Under 460 tons of pulling force, the main drive unit slowly lifts until it stands upright at 90 degrees. Next, it continues to move at a pace of 0.5 meters per second, gliding through the air with perfect posture and precise alignment. Finally, the main drive unit successfully integrates with the main beam.
Before we produced our first machine, over 90% of the equipment had to be imported. In over a decade, we went from nothing to something, building our own brand from scratch by mastering core technologies. We freed ourselves from dependency on others.
Over 1,600 kilometers away, the sister model of CREC 1098, the world's first large-diameter hard rock TBM designed for high-altitude, cold climates, Snow Pioneer, is working at full power. For the first time, China is using a hard rock TBM for tunnel excavation in such challenging conditions. After more than half a century of practice and accumulation, China has become the global leader in tunnel construction, with the most tunnels, the largest construction scale, and the fastest development speed. With leaps in construction and equipment technology, China continues to achieve major breakthroughs in mechanized and intelligent construction of long tunnels in high-altitude, cold regions. Among the world's top 10 highest bridges, 8 are in China. Among the world's top 10 longest cable-stayed bridges, 7 are in China. Among the world's top 10 longest suspension bridges, 6 are in China. However, for China's bridge builders, who regularly set world records, this is not enough. In Wenzhou, Zhejiang, the Wenzhou-Ojiang North Estuary Bridge, the world's first 3-tower, 4-span steel truss suspension bridge, is under full-speed construction. However, before this, the project faced a significant challenge.
The Wenzhou-Ojiang North Estuary Bridge is a crucial section of the Ningbo-Dongguan Expressway connecting Ningbo and Dongguan. It also forms an essential part of National Highway 228. One standout feature of this project is the use of a high-rigidity concrete central tower within the long-span multi-tower suspension bridge structure.
This innovative design maximizes the bridge's wind-resistant stability. However, it also demands an absolutely reliable main cable saddle. The Wenzhou-Ojiang North Estuary Bridge spans 7.9 kilometers, with a river crossing of 2,090 meters. It is designed with two main cables, each capable of lifting around 1.5 Liaoning aircraft carriers. What kind of main cable saddle can handle such immense loads? Rising to this challenge is a company in Sichuan specializing in manufacturing core load-bearing components for bridges. Huang Aming is the technical lead responsible for process experiments and R&D. For Ojiang North Estuary Bridge's main cable saddle.
The design of the Ojiang North Estuary Bridge includes a high-rigidity concrete A-shaped central tower, which places rigorous demands on the main cable saddle at the top of the tower. The friction coefficient between the saddle groove and the main cable strands must meet the minimum anti-slip safety requirement, which must be increased from 0.15 to over 0.3. Traditional main cable saddle structures simply cannot meet this requirement.
With no established experience to draw upon, the research team started their work from scratch. Through extensive studies, simulations, and verifications, they developed a structural design incorporating vertical friction plates within the saddle groove. These plates significantly enhance the friction, thereby improving the overall anti-slip performance of the main cable saddle. This design passed the evaluation. A giant crane arrives, flipping and rotating a 170-ton steel block. Precision manufacturing of the first main cable saddles for the Ojiang North Estuary Bridge has officially begun. Today's lead technician is Luo Guihui. Over 17 years, he has worked on more than 80 core bearing components for bridges. Facing the main cable saddle challenge for the world's first three-tower four-span suspension bridge, Luo remains undaunted. The 5-axis CNC milling and boring machine, the pinnacle of Chinese machine tools, gives him ample confidence. The jack is in place. The main cable saddle remains perfectly still. The dial gauge makes precise adjustments. Alignment between the main cable saddle and the machine tool is complete. The 250mm diameter carbide cutter is installed. The 5-axis CNC machine begins cutting at 600mm per minute. The cutter moves smoothly against the main cable saddle, with the curved saddle groove rotating steadily, precisely machining the target area, maintaining a flatness error of no more than 0.08mm. This is the synergy between Luo Guihui and the cutter, representing their shared goal.
Every time we complete a bridge, the company usually takes some on-site photos. Looking at those pictures fills me with an immense sense of pride. We often joke saying, "Look at that main cable saddle, you worked on that." It really is something to be proud of. My biggest wish is that, when I retire, I can visit each bridge I've worked on, stroll around and reflect on our achievements.
Meanwhile, another crucial manufacturing task is underway. Vertical friction plates installed in the saddle groove enhance the overall anti-slip performance of the main cable saddle. This design relies on full penetration welding technology. However, the gap between the vertical friction plates is only 61mm, making manual welding extremely challenging. A narrow gap welding robot. Took on the challenge and successfully completed all vertical plate welds in one go as expected. with 100% ultrasonic inspection pass rate. It perfectly resolved a critical manufacturing issue for the main cable saddle of the Ojiang North Estuary Bridge's central tower. Preparing to lift. After nearly 3 hours of intense effort, the first main cable saddle for the central tower of the Wenzhou-Ojiang North Estuary Bridge has been successfully installed. However, the bridge's completion and commissioning still hinge on one final critical step. The soon-to-be-opened Wenzhou-Ojiang North Estuary Bridge is about to welcome its first heavyweight visitors, 144 heavy trucks, with a total weight of nearly 5,000 tons, will enter the upper and lower decks of the main span to conduct static and dynamic load tests on the bridge. This is the largest static load test ever conducted on a Chinese highway bridge to date. The results indicate that the high-rigidity central tower and other structural elements are safe and reliable, laying a solid foundation for the successful opening of the Ojiang North Estuary Bridge. Bridges, the pinnacle of transportation infrastructure. Behind the construction of these large-scale bridges lies the development of new materials, intelligent manufacturing, advanced equipment, and state-of-the-art information technology. Over more than half a century, China's bridge construction technology has reached the forefront internationally. The completion of world-class bridges is transforming China from a major bridge builder to a leading bridge powerhouse, significantly contributing to global bridge engineering. Manufacturing is a cornerstone of a nation's overall strength and international competitiveness. Since the 18th National Congress, China has firmly pursued initiatives to strengthen its industrial foundation and upgrade its foundational industrial infrastructure. Over the past decade, we have navigated challenges and achieved a historic transformation in equipment manufacturing, laying a solid foundation for high-quality development. China's influence in the global industrial and supply chains continues to rise. Chinese equipment, powering the world. Looking ahead, China's manufacturing industry will maintain its commitment to independent innovation. On our journey toward achieving the second centenary goal, we will strive for self-reliance, tackle challenges head-on, and work tirelessly toward the grand vision of becoming a manufacturing powerhouse.